Welcome everyone in this video. Question number 1. To determine the modulus of rupture, the size of test specimen used is 150 mm into 150 mm into 700 mm. Option C is right answer. Question number 2. The property of fresh concrete in which the water in the mix tends to rise to the surface while placing and compacting is called bleeding. Option B is right answer. And segregation is the property of fresh concrete in which the coarser aggregates tend to separate from each other while compacting. And bulking is found in sand, which is the bulging of volume due to increase in moisture content. And creep of concrete is the elastic and long term deformation under sustained load. Question number 3. Select the incorrect statement. Statement A. Lean mixes bleed more as compared to rich ones. The cement concrete mixes where cement content is less than 10% is known as lean mix concrete, and in these mixes the bleeding is more as compared to rich ones. There are three type of mixes in cement concrete: lean mixes concrete, normal mixes concrete, and rich mixes cement concrete. So in case of lean mixes cement concrete, the cement content is less than 10%, and in case of normal concrete the cement content is between 10 to 15%, and in case of rich mixes concrete the cement content is more than 15%. So in case of lean mixes, bleeding is more as compared to rich ones, as the quantity of cement is less and water is more. Statement B. Bleeding can be minimized by adding pozzolana, finer aggregate. Correct. Statement C. Bleeding can be increased by addition of calcium chloride. No, it can be reduced by addition of calcium chloride. So option C is the incorrect statement. E is right answer. Question number 4. The property of the ingredients to separate from each other while placing the concrete is called segregation. Option A is right answer. And compaction is the process of reducing the air voids from the concrete. And shrinkage is the contraction of the volume of concrete due to some chemical reaction into the concrete or cement content. And bulking is the bulging of volume which is found in sand, which is due to the increase in moisture content. Question number 5. Workability of concrete is directly proportional to the grading of the aggregate. Option C is right answer. Because if the aggregates are well graded into the concrete mixes, then the workability of the concrete will be more. Option C is right answer. Aggregate cement ratio, no. If the aggregate cement ratio is more, the workability of the concrete is less. Option B. Time of transit, no. Time of transit is the time between the mixing the concrete and placing the concrete. So if the time of transit is more, the workability will be less. And option C. Grading of the aggregate. If the aggregates into the concrete are well graded, then the voids will be less, so the workability of the concrete will be more. Option C is right answer. Question number 6. Workability of concrete is inversely proportional to the time of transit. Option A is right answer. And directly proportional to the water cement ratio, air in the mix, and size of the aggregates. Question number 7. Approximate value of shrinkage strength in concrete is 0.0003. Option B is right answer. Question number 8. Air entrainment in the concrete increases workability. Option A is right answer. This is called air entrainment concrete, in which air is intentionally injected into the concrete. Option A is right answer. Question number 9. The relation between the modulus of rupture FCR, splitting strength FCS, and direct tensile strength FCT is given by. Look, we know the relation approximately. Direct tensile strength FCT is equal to 0.5 into modulus of rupture FCR, and splitting strength FCS equal to 0.66 into FCR, which is the modulus of rupture. This is equation 1 and this is equation number 2. So from these two equations we can write FCR greater than FCS, which is also greater than FCT. Option B is right answer. Question number 10. The approximate value of the ratio between the direct tensile strength and flexural strength is 0.5. Option B is right answer because we know the relation direct tensile strength FCT is equal to 0.5 into FCR, which is the flexural strength of concrete. Option B is right answer. Question number 11. Strength of concrete increases with the increase in fineness of cement, because if the fineness of cement increases, the reaction between the cement and water will take place more rapidly, increasing the strength of concrete. Option B is right answer. Question number 12. The relation between the modulus of rupture FCR and characteristic strength of concrete FCK is given by. Option C is right answer. FCR equal to 0.7 into root over FCK, where FCR and FCK are in Newton per millimeter square. Question number 13. The compressive strength of 100 mm cube as compared to 150 mm cube is always more. Option B is right answer. Question number 14. According to IS 456/1978, the modulus of elasticity of the concrete EC in Newton per millimeter square can be taken as is equal to 5700 into root over FCK. Option A is right answer, where FCK is the characteristic strength in Newton per millimeter square. Question number 15. Increase in the moisture content in concrete reduces the strength. Option A is right answer, as because the excess of water creates space between the aggregates into the concrete and some voids are created into the concrete, and after when the water evaporates, the voids fill with air, entrapped air, which decreases the strength of concrete. Question number 16. As compared to ordinary Portland cement, use of pozzolanic cement increases shrinkage. Option C is right answer, as pozzolanic materials, namely fly ash, volcanic ash, are added to the OPC so that it becomes PPC, Portland pozzolanic cement. Question number 17. Admixtures which cause early setting and hardening of concrete are called accelerators. Option B is right answer. Question number 18. The most commonly used admixture which prolongs the setting and hardening time is gypsum. Option A is right answer. Question 19. The percentage of voids in cement is approximately 40%. Option B is right answer. Question number 20. The strength of concrete after 1 year as compared to 28 days strength is about 20 to 25% more. Option C is right answer. The strength of concrete at the end of one day is equal to 16%, and at the end of 3 days it is 40%, and at the end of 7 days the strength becomes 65%, and at the end of 14 days the strength becomes 90%, and at the end of 28 days the strength becomes 99%. Question number 21. As compared to ordinary Portland cement, high alumina cement has higher initial setting time but lower final setting time, because OPC has initial setting time of 30 minutes but higher alumina cement has initial setting time of 3.5 hours. But in case of OPC the final setting time is 10 hours, but in case of high alumina cement the final setting time is 5 hours. So option A is right answer. Question number 22. Modulus of rupture of concrete is a measure of flexural tensile strength. Option A is right answer. Question number 23. In order to obtain the best workability of concrete, the paper shape of aggregate is rounded. Option A is right answer, because rounded aggregate has less voids as compared to others. Question number 24. The effect of adding calcium chloride in concrete is to increase shrinkage and to decrease setting time. 1 and 4. Option B is right answer. Question number 25. Bulking of sand is maximum if moisture content is about 4%. Option B is right answer. An increase in moisture content in sand of 4% can increase bulking of cement up to 25%. Question number 26. Final grinding of cement affects only the early development of strength. Option A is right answer. Question number 27. Poisson's ratio of concrete increases with richer mixes. Option B is right answer. Question number 28. 1% of voids in a concrete mix would reduce its strength by about 5%. Option A is right answer. Question number 29. The fineness modulus of fine aggregate is in the range of 2 to 3.5. Option A is right answer, and the fineness modulus of mixed aggregate is between 5 to 7, and that of coarse aggregate is between 6 to 8.5. Number 30. The factor of safety for steel is lower than that for concrete. Option B is right answer, because steel is manufactured under the controlled environment into the factories. Okay, and concrete is prepared on the field. So that's why factor of safety is more for concrete and lower for steel. Question number 31. Examine the following statements. Statement 1. Factor of safety for steel should be based on its yield stress. Right? Yield stress is the stress at which a material deforms plastically, meaning it does not return to its original shape after the stress is removed. So factor of safety for steel should be based on its yield stress because it ensures that the material will not deform plastically and will remain within its elastic range. Statement 2. Factor of safety for steel should be based on its ultimate stress. No, factor of safety based on yield stress is more conservative than based on ultimate stress. Ultimate stress is the maximum stress a material can withstand before it fails. The factor of safety for steel can also be based on ultimate stress, but this is less conservative than one based on its yield stress. This approach assumes that the steel will not deform plastically before it fails, which is not always the case. Statement 3. Factor of safety for concrete should be based on its yield stress. Concrete is a brittle material that does not exhibit a clear yield point. The factor of safety for concrete should be based on its compressive strength at a certain percentage of its design strength, which is considered as its yield strength. This ensures that the concrete will not fail in compression before it reaches its design strength.
Not correct.
Statement 4. Factor of safety for concrete should be based on ultimate stress.
Correct statement.
Ultimate stress, which is the maximum stress it can withstand before it fails. So statement 1 and 4 are correct. Option B is right answer. Question number 32. For a reinforced concrete section, the shape of shear stress diagram is parabolic above the neutral axis and rectangular below the neutral axis. Option C is right answer. Question number 33. Diagonal tensile in a beam increases below the neutral axis and decreases above the neutral axis. Option C is right answer. Diagonal tension is caused by shear and occurs in beam's tensile zone, which is below the neutral axis. The combination of shear and tensile stress increases the diagonal tension below the neutral axis, and shear reinforcement is provided to prevent the diagonal tension crack. Question number 34. If a beam fails in bond, then its bond strength can be increased most economically by using thinner bars but more in numbers. Option B is right answer. To increase bond stress, we should use smaller dia bars in large numbers to keeping the area same. Question number 35. If nominal shear stress tau V exceeds the design shear strength of concrete tau C, the nominal shear reinforcement as per IS 456/1978 shall be provided for carrying a shear stress equal to the tau V minus tau C. Option C is right answer. Question number 36. If the depth of actual neutral axis in a beam is more than the depth of the critical neutral axis, then the beam is called over-reinforced beam. And if the depth of actual neutral axis in a beam is less than the depth of the critical neutral axis, then the beam is called under-reinforced beam. Question number 37. If the depth of neutral axis for a single reinforced rectangular section is represented by KD in working stress design, then the value of K for valence section. We know the value of K equal to M sigma CBC divided by M sigma CBC plus sigma ST. That is equation number 1. And we also know that M equal to 280 by 3 sigma CBC for a balance section. So if we put the value of M equal to 280 by 3 into sigma CBC into equation number 1, we will get K equal to 280 by 3 divided by 280 by 3 plus sigma ST. So from this equation we can say the value of K does not depend on sigma CBC but only depends on sigma ST.
Option A is right answer.
Question number 38. If the permissible stress in steel in tension is 140 Newton per millimeter square, then the depth of neutral axis for a single reinforced rectangular balance section will be. We know depth of neutral axis equal to K into D. This is equation number 1. And we also know that the value of K equal to 280 by 3 divided by 280 by 3 plus sigma ST into the effective depth D. And as per question, the value of sigma ST equal to 140 Newton per millimeter square. So if we put the value of sigma ST into this equation, we will get the depth of neutral axis equal to 0.40 into D. Option B is the right answer. Question number 39. Modulus of elasticity of steel as per IS 456/1978 shall be taken as 200 kN per millimeter square. Option C is right answer. Question number 40. Minimum grade of concrete to be used in reinforced concrete as per IS 456/1978 is M15, but as per IS 456/2000 it will be M20. Question number 41. For concreting of heavily reinforced section without vibration, the workability of concrete expressed as compacting factor should be above 0.92. Option D is right answer. Question number 0.42. Maximum quantity of water needed for per 50 kg of cement for M15 grade of concrete is 32 liters, and for M20 grade is 30 liter. Option C is right answer. Question number 43. In case of hand mixing of concrete, the extra cement to be added is 10%. Option B is right answer. Question number 44. For walls, columns, and vertical faces of all structural members, the formwork is generally removed after 24 to 48 hours. Option A is right answer. Question number 45. The individual variation between test strength of samples should not be more than 15 plus minus 15% of the average. Option C is right answer. Question number 46. One of the criteria for effective width of the flange of the T-beam is breadth of flange BF equal to L0 by 6 plus BW plus 6 DF, where L0 is the distance between the points of zero moments in the beam. Option B is right answer. DF is the depth of flange and BW is the breadth of wave. Question number 47. For a cantilever beam of effective depth of 0.5 meter, maximum span to satisfy vertical deflection limit is. In case of cantilever beam, for limiting the vertical deflection, we know the span by effective depth ratio is equal to 7. And from the question we have got effective depth equal to 0.5 meters. So if we put the value into this equation, we will get span equal to 7 into 0.5 equal to 3.5 meter. Option A is right answer. Question number 48. For a simply supported beam of span 15 meter, the minimum effective depth to satisfy the vertical deflection limit should be. We know in case of simply supported beam, for limiting deflection, the ratio between span by effective depth equal to 20 if the span is less than or equal to 10 meter, and if the span is greater than 10 meter, then the span by effective depth ratio becomes 20 into 10 by span. So as per question, the span is greater than 10 meters, so we have to use equation number 2. So for equation number 2, span by effective depth ratio is equal to 20 into 10 by span. We know span is equal to 15 meter, so if we put the value into this equation, we will get span by effective depth ratio is equal to 40 by 3. That is equation number 3. Now if we put again the value of span equal to 15 meter in this equation, we will get effective depth is equal to 1.125 meter.
Option D is right answer.
Question number 49. For a continuous slab 3 meter into 3.5 meter size, minimum overall depth of slab to satisfy the vertical deflection limit is. For simply supported slab with shorter span less than 3.5 meter, the span by depth ratio is equal to 35 for mild steel reinforcement, and the span by depth ratio is equal to 28 for HYSD bars. And for continuous slab with shorter span less than 3.5 meter, the span by depth ratio is equal to 40 for mild steel reinforcement, and span by depth ratio is equal to 32 for HYSD reinforcement. So from the question we know the continuous slab of 3 into 3.5 meter dimension, so shorter span is less than 3.5 meter, and say the continuous slab casted with mild steel reinforcement. So from equation number 2, span by depth ratio is equal to 40, and we know the shorter span value is 3000 mm or 3 meter, so the depth will be equal to 3000 divided by 40 equal to 75 mm. Option B is right answer. Question number 50. According to IS 456 1978, the flexural strength of concrete is directly proportional to the square root of the compressive strength. Option C is right answer, because we know flexural strength FCR equal to 0.7 into root over of FCK,
Where FCK is the
compressive strength of concrete.